Okay, in this video I want to talk about polynomials, and we want to talk about the degree and the number of terms, just some terminology when talking about polynomials. So in the next problems, what we're going to do is determine if they are polynomials. If they are, we're going to talk about the degree and just the number of terms. So I've got 4 examples on this page. I'm actually going to do 3 others as well. So remember, a polynomial, for me to pick out a polynomial, what we need, okay, so I look for x's. I don't really want x's in the denominators. So if I see any x's in the denominators, I rewrite them, and I pull them up in the numerator. If there's any simplifications I can do, I also do all the simplifications. But then what I'm looking for is the exponents need to be positive whole numbers, positive integers. Well, 8 is a positive integer, 7 is a positive integer. The exponent on the x over here is a 1. That's also a positive integer. So this would qualify as a polynomial. You can have any old number in front as coefficients. So 3 is fine, negative pi is fine, positive 4 is fine. So we would say, yes, this is a polynomial. Okay. And when we talk about the degree is just the largest exponent. So here it's to the 8th power. So we would say this has a degree of 8. And lastly, we talked about the number of terms. To me, to see terms, those are the things separated by pluses or minuses. So to me, that's a term. I see another thing in between a plus or a minus, and I see another thing. Technically, you need to take the sign with it. So one term would be 3x to the 8th. I would say another term is negative pi x to the 7th, and then positive 4x. But there's 1, 2, 3 things. So there are 3 terms. And in this case, we call this a trinomial. So just like a tricycle has 3 wheels, a trinomial has 3 terms. Alright, so maybe let's go through these a little faster. 2x to the 8th minus 5 times the square root of x to the 20th. So maybe it would be easy to say, well, the degree is 20 because I see an x to the 20. But again, we have to simplify this first. So this is 2x to the 8th minus 5x to the 20th raised to the 1/2 power. And again, the exponent only applies to the x. So notice the 5 is not in the parentheses with it. We get 2x to the 8th minus 5x. If it's in parentheses, we multiply. So that would give us to the 10th power. But again, based on what we said before, I look at my x's. Hey, those both have positive integers as exponents. So we would say, yes, this is a polynomial. The degree is, again, the largest positive whole number that we see. So in this case, we would say this has a degree of 10. And notice there's 1, 2 terms. If there's 2 terms, we call this a binomial. Okay, kind of like a bicycle, hey, 2 wheels. So let's go to our next one here. 2x to the 10th plus 5 divided by x squared minus 8. It might be easy to say, hey, that's a polynomial because I see an x to the 10th. Sorry about my little stray mark. I see an x to the 10th and an x to the positive 2nd. But again, always rewrite these so that the x's are not in the denominator. Well, I could bring the x squared upstairs as x to the negative 2nd. But now, again, the x's have to be positive whole numbers. Okay, so the x to the 10th is fine, but this negative 2 is messing things up. So we would say, no, this is not a polynomial. And if it's not a polynomial, we don't talk about degree or any of that. When we talk about degree, it's understood that we're talking about polynomials. Alright, so let's look at this next one here. So 3x to the 7th plus 2 times x to the 7th minus 1 minus 5 times the quantity x to the 7th plus x squared. To me, it looks like positive whole numbers as exponents. It might be easy to say the degree is x to the 7th, but let's simplify this down first. We would have to distribute the 2, so we would get 2x to the 7th. When we distribute the positive 2 and the negative 1, we would get negative 2. then we would have negative 5x to the 7th, and negative 5 times a positive x squared is negative 5x squared. Notice if we combine our like terms, our 3x to the 7th plus our 2x to the 7th would give us 5x to the 7th minus 2 minus 5x to the 7th minus 5x squared. But now our 5x to the 7ths actually cancel out, and we're just left with negative 2 and negative 5x squared. And I'm just going to rewrite that as negative 5x squared minus 2. Okay, so I look at my exponents. Hey, the x has a positive integer as an exponent. You can have any old numbers hanging out here that you want to. I should really be careful because I say the x's have to be raised to positive whole numbers. You know, the x's that you see need to be raised to positive whole numbers. You can always write x. You can write, for example, negative 2 is negative 2x to the 0 because x to the 0 equals 1. So technically all the exponents are non-negative integers, but we never really write that. We just write 5x squared minus 2. So hey, I see an x sitting there, and yes, it does have a positive integer associated with it. So we would say yes, this is a polynomial. This has degree 2, and degree 2 polynomials are sometimes what are called, well, oftentimes, those are called quadratic. Okay, so, and once the degrees get pretty big, for example, like 10, we would just say, well, that's a degree 10 polynomial. But degree 2 polynomials are very common, and we actually give those their own little name. We say it's quadratic. Again, it has 1, 2 terms, so we would say this is binomial. All right, so just a couple more examples here. I guess 3 more examples. So here we have 2x to the 5th plus the square root of x minus 7. Again, I would rewrite this with just exponents. That's 2x to the 5th minus x to the 1/2 minus 7. Well, again, this is not a polynomial because this x is being raised to a number that is not a positive integer. Okay, so it is a positive number, but we need positive whole numbers. So we would say no, not a polynomial. Okay, negative x to the 3rd, that's definitely going to be a polynomial. There's not a lot really going on there, but that's okay. The exponent here is a 3, which is a positive integer. So the degree in this case, we would say it has degree of 3. And since there's only one term, we call that a monomial. Okay, kind of like a monocle, you know, in the old 1800s or early 1900s, they had the one glass. That's how I always remember it, a monocle. So there's just one thing, which is a monomial. All right, last but not least, we have 1 over 600 x squared plus root 2 over pi x to the 1st plus 4 to the 10th. Again, my x's that I see have positive whole numbers associated with them. So I would say yes, this is a polynomial. And then what's the degree? Well, you have to be careful. It might be easy to say it's degree 10 because, well, that's the biggest exponent I see. But the degree, we just have to look on the x's, okay? So I look at my x's, the biggest exponent is 2, so I say it has degree 2, which is, again, a quadratic. Since there's 1, 2, 3 terms, we call it, again, a trinomial. So again, just terminology, you know, sometimes this is why they say, hey, math is another language, because you certainly are always learning new words, and any instructor is going to use the terminology. So, you know, certainly get familiar with it. If there's ever a term you don't know, just look it up. It's always, you know, a good idea. It's amazing how many people don't do that, in fact. And, you know, if you don't know the language, then, you know, how can you do the problem? So, all right, I hope these examples make some sense.